So in this problem for part C, what we want to do is find the required sample size in order to reduce our margin of error by 50%. So you already found the margin of error in part B, that's right here. So to reduce it by 50%, we will multiply by 0.5, and that gives us a new margin of error of 105.575. Now recall, our formula for the margin of error is our z value times our standard deviation divided by the square root of n. So now we'll just plug in all the pieces we have. We have our revised margin of error, or our E, at 575. We've got our z value, because it's a 95% confidence interval, which is 1.96. Our standard deviation was given to us, and we will multiply that. So there's their 1481. And then what we don't know is the square root of n. Now this is the algebra that you may or may not recall from high school, but here we want to isolate n by itself on one side in order to solve for it. So first we want to multiply both sides by the square root of n to get rid of the square root of n in our denominator. So when I multiply it, it's going to go over this way, for instance, and get rid of it on this side. So it becomes our square root of n times 105.575 equals 1.96 times our 1481. I haven't simplified everything just yet. Now, I still want my n by itself though, so I'm going to, in order to get rid of my 105.575 on this side, I will divide both sides by the 105.575. 105.575. So when I get rid of that, now what I'm left with is the square root of n equals 1.96 times 1481 divided by 105.575. So let's simplify that sum, which is essentially 2,902.76. That's my top here where I multiply 1.96 by 1481. And I'm going to divide it by my 105 of 0.575. That gives me 27.4947. But I'm not done, because essentially my 27 here is this square root of n. So what we want to do is get rid of the square roots. And in order to do that, so let me just rewrite it like this. Therefore, equals 27.4947. In order to get rid of the square root, we have to square both sides. So I'm going to square both numbers. And what happens is my n is now equal to 755.96. But remember, with required sample sizes, we always round up. So my n becomes 756. So hopefully that helps. Let me know if you have any questions.